Alright guys, welcome back to Redstone for Dummies. In today's video, we're gonna go over some more complicated stuff, but I'm pretty sure that's what you guys have been waiting for since the beginning. So in this video, we're gonna be going over the NOT gate. So let's begin with what is a NOT gate. A NOT gate is basically something you're gonna build that will inverse your signal. So here I've got a NOT gate on this circuit right here, and both levers are turned on, but as you can see, only that redstone lamp there is on. So if I turn it off, it goes off. It's pretty straightforward. And here, if I turn it off, it goes on. If I turn it on, it goes off. It's the opposite. That's what a NOT gate will do. Alright, so before we go into how you build one, I'm gonna go over what type of color code I'll be using in the next videos. First of all, I've got a color for redstone dust. So anywhere that I'm going to put redstone dust, I'll try to my best, if I can, to have a light blue wool beneath the redstone dust. If I have to put a redstone torch down, I'm going to try to have a light green wool block beneath the redstone torch. And same goes for levers. If I can, I'm going to put the lever on an orange wool block. So yes, I said 3 times that if I can, or I'm gonna do my best, I'll try to. That's because sometimes you can't always do both at the same time. So here I've got a lever and a redstone dust on the same block, so I have to choose whether it's the light blue block or orange block. So here I'm gonna do both. If I can't put it on the block itself, I will always try to put it beneath the block right here. So the lever here and the orange block right there. Same goes for the redstone torch that's right here. So I'll try to put the block beneath the object. I can't always, if I can't just put it on the block itself. I'm sure you guys get the point. Same thing goes here for a redstone torch with redstone dust. And again, a lever on this side. And here we've got just a redstone torch behind the lever. Sometimes I might even need to use the 3 colors at once. So here I've got a lever on a block that has redstone dust on it, orange wool. On the other side here we've got the green wool for the redstone torch. So again, just bear in mind that I'm doing my best, but I'll try to follow these principles. Light blue for redstone dust, orange for levers, and green for redstone torches. So a NOT gate is built like this basically. So that's kind of the most simple way to build a NOT gate. When you turn on the lever here, it's going to output current that will power this block. This torch will turn off, and then the redstone lamp will go off. And opposite happens when it's off here. Torches go on, and then that goes on, turns on the redstone lamp. So here is a quick example. Now the lever is off, redstone lamp is on. Turn it off. That goes on, this goes off, and then it goes off. So it's always the opposite when using a NOT gate. Alright, so it doesn't really matter where you place your redstone torch in the NOT gate circuit, if you call it like this. So basically, as long as you have the torch and you have a way to turn it off and on, that's always gonna work basically. So here, doesn't matter where I've put it, even on the block itself here, it always works. All these levers are off, all these pistons are extended, so the current is reversed. And you can even put more than one torch on the same circuit, but as long as you have an odd number of torches. Otherwise, it will just reverse the current back to what it's supposed to be. So here I've got 2 torches, current is off, it gets turned on with the redstone torch and then goes back off, so it's the same output as the input here. And again, you have to use another number, turns on, turns off, and then turns back on for a lever that's turned off. So that's a good thing to know. Always have an odd number of torches. Alright, so now we're getting into some more complicated stuff. These are also NOT gates. They're just different looking. They still work the same. It always reverses the current. That's what a NOT gate does. And they're just a little bit more complicated. Again, you can choose to whether use it or not. It's just a different design. You're going to have to adapt your NOT gate to whatever situations you have. So here's a quick example. We've got this NOT gate here, which I'm going to try to explain as simple as I can. So this redstone dust gets turned on when the lever is on, which will power that redstone torch off, which doesn't turn on that block, and then that block will not output a signal to power whatever you have on this side. But if you turn on the lever, that goes off. I destroyed it. That goes off. Torches goes on. block goes on, outputs a signal, and then these pistons extend. So again, the lever is not there. It's so on, it turns off, turns on. So again, that's what a NOT gate does. Here, using the subtract function of a comparator, you can also have a NOT gate. I've got this lever here that's turned on, which powers this repeater, which is right beside the comparator. Here we've got a signal strength that has a level of 15 because it's right beside it. And if I turn on this lever here, it should technically also create a signal of 15, and if we do the subtraction, 15 minus 15 is 0, so nothing will be outputted. And here, if you turn off the lever just like that, this signal goes off. We still have the 15 strength here, so if we go 15 minus 0, it's 15, so the output here is 15, and then it powers whatever you have on this side. So again, it's turned off, and the end is turned on. If I turn it on, it goes off. It's again the opposite. The only thing is that this circuit is L-shaped. It might not always work for you, and this is why we've got the same one, but in a almost line shape. So same principle, we've got this lever that's turned on, powers this, and also even if it's not right beside the comparator, this Redstone dust still has a strength of 15, so it's still going to count as 15 inside the comparator. And now the lever is on. That means that we again do 15 minus 15, and 0 is the output. If I turn it off, it's going to reverse 0, 15, 15 minus 0, we get 15, and that's what we get as the output. Again, lever is off, piston is extended, lever is on, piston retracts. So if you thought the previous two gates were complicated, you haven't seen this one. I'm not really gonna try to explain it. I'll just leave a link for the Minecraft wiki page where you can see all these designs. Basically, it's still the same principle. You turn on the lever. Right now it's on. These pistons are off. And if I turn it on, you're gonna see that they go on. So it's, again, always the opposite. Retract them, expand them, always the opposite. Now, this design, as well as this one here beside me, is special. They have a 0 tick delay. So as soon as I turn on or turn off the lever, these pistons will go on or off as soon as I do it. Again, there is a 0 tick delay. It's instantaneous. So again, turn it on, off. You see how fast they are going? It's so fast, the pistons are kind of glitching. You're gonna see that if I come back to this NOT gate, there's a small delay between the switch and the piston. So here I turn it on. You see it's not really instantaneous. That's what this gate has that's special. It's just instantaneous. There we go. Same thing goes for that one behind me. So it again looks sick, looks complex. It is complex. And so yeah, here again, 0 delay. It's just so fast the pistons can't keep up, but you get the point. Alright guys, that will do it for today's video. I hope you enjoyed that. I hope you now better understand what a NOT gate is. If you do, please click the like button, subscribe, share the video, go to my Facebook page, do everything, and then you're going to be able to keep up with all the videos coming out every day. So again, thanks for watching guys, and have a good day.